my name is Vic Parachuri, and today we're going to walk through a machine learning project together. And in this project, we're going to be predicting the weather using historical data. And this is a project for beginners. So we're going to start with downloading the data, we're going to prepare the data for machine learning, and then we're going to train our machine learning model and evaluate how well it did on our data set. And then we're going to end with some next steps you can take to continue the analysis and make it more effective. Let's go ahead and get started. We're going to start by downloading the data. And we can do that from the NOAA website. NOAA, N-O-A-A, is the US government agency that has weather forecasts and other data. It actually has data from around the world. Not every country, but many countries. So regardless of where you live, you should hopefully be able to find a weather data set close to you that you can actually download and make predictions with. So I'll show you how to do that. So we start with this website. You can see the URL up here. We're going to select daily summaries. So this will give us one row in our data set for every day. And it'll give us data like the maximum temperature that day, the minimum temperature that day, etc. We're going to select a long date range. So I'm going to select from 1960 through the present. Feel free to select a different range if you want, but I'd recommend trying to get a lot of rows if you can. Search for stations, and then I'm going to search for Oakland Airport. That's the closest airport to me. I would recommend searching for an airport because they tend to have the best temperature sensors and other things that you'll need to make predictions with. It ensures that you have a lot of columns and that you don't have any missing data. So I'm going to search for Oakland Airport, and this top result on the left is Oakland Airport near me. So I'm going to add it to my cart. Now I click on the cart, I hit view all items, and this lets me configure some things about the data before I download it. So I'm going to select CSV. I want a daily CSV. I'm going to confirm the date range, and then I'm going to hit continue. All right. So finally, I can select the types of data I want. So I'm going to select everything, which is actually select all, and then I'll hit continue. All right. So this is just a review of everything that I already entered. So I want data from Oakland International Airport. I want all of these data types, and I want this date range. So what you would do now is just enter your email address and submit your order. So just enter your email and hit submit order, and you will get an email short that has a link to download the dataset. I already downloaded the dataset. For now, I'm going to jump back to the notebook. We'll now go back to our notebook interface where we can actually start. So you'll see there's two files in the Jupyter Lab interface here on the left. So this local weather.csv file is actually the file we just downloaded. Hopefully you just downloaded it. So we can go ahead and take a look at this file and see what the format is. So my data is from Oakland International Airport. Your data may be from somewhere else, depending on which airport you selected or which location you selected. But each row is a date. So my data starts on January 1st, 1960, and each column indicates a weather observation about that date. So here we can see there was no precipitation that day, there was no snow, and the maximum temperature was 49, the minimum temperature was 30. So we can go into more detail about these columns later, but I just wanted to give you a quick look at what the data looks like. So let's jump back to our notebook, and we can go ahead and start coding. So the first thing we want to do is actually read the data in. And we'll actually load it into Python using a library called pandas, which you've hopefully used in the past. So we'll import pandas as PD, and then we're going to go ahead and read our data into the weather variable using the pandas read CSV function. So our file is called localweather.csv. Yours may be named differently if you downloaded it. And we will specify an index column. So you may have noticed in the data, if we go back, that there is a date column. We actually want this to be our index column in pandas. The index column in pandas makes it really easy to use that column to actually look up values in specific rows. So we'll just specify that the date is our index column. And you'll see more later about the index column and how specifying date as the index can help us. So let's run that, and let's just take a look at what we just read in. So we can see the date column on the left, that's our index. And we can see all of the data that we saw earlier when we looked at the CSV file. So here's an example of how you can use the index. So if we only want to look at data for the first day in 1960, we can do this. If we want to look at data from a specific range, so let's say only data from January 1960, we can also do that. And having the index set as our date makes it really easy to get slices of our data for specific date ranges. All right, so let me get rid of that and let's continue. So the first thing we're going to want to do is clean up our data to get it ready for machine learning. And most machine learning algorithms don't deal well with missing values. So the first thing we want to do is fix any missing values in our data set. So let's first find out which columns have missing values. So we'll do that by using the apply method on the weather data frame. And we'll pass in the pandas isNull function. So what this will do is go column by column through the weather data frame and look for any null values. And then we'll say .sum. So this will give us a count of all the null values in each column. It's a little bit hard to look at it when it's just raw numbers. So let's go ahead and convert this to percentages. So we'll divide it by the number of rows in weather, which is just weather.shape 0. And this gives us the percentage of null values in each column. So you can see some of these columns have a high percentage of nulls. 99.9% of the values in this column are missing. All right. So the next thing we want to do is figure out what to do with some of these null or missing columns. And one thing we can use that helps us is the data documentation. So I'll zoom out a little bit here so you can see the URL. But if you downloaded the data set, you should have received this in an email. So what this tells you is documentation about the data. And whenever you download a data set or use a real-world data set, always see if you can find documentation, because that helps you understand the data and what each column means. So in this case, I've gone to page 5 in this PDF documentation, and this tells us there are 5 core values in our file: precipitation, snowfall, and temperature. And there are a lot of other values, but these core values are the most important ones. So for now, we're going to actually only look at these core values because we assume these are the highest quality measurements. These are probably the ones that are the most accurate and probably have the least missing values also. So let's go ahead and jump back to our notebook, and we will go ahead and just only select a few columns, the ones that are considered core. So, and what's considered core is in the documentation. That's not a general data concept. It's specific to this data set where Noah, who created the data set, said, hey, these are actually the most important columns. So those are PRCP, precipitation, snow depth, which is the amount of snow on the ground, temperature max, Tmax, and temperature min. These are the maximum and minimum temperatures in a given day. And then we'll just copy this. So we're taking a few columns from our data set. We're copying them into a new data frame called core weather. All right, and then in core weather, let's just go ahead and rename the columns so they're a little bit easier to work with. Some people like typing in all caps. I do not. So let's remove the caps here. So we'll call these precip, snow depth, temp max, and temp min. And these will be our new column names. So we'll assign it to the column property. And we can take a look at core weather now. And we can see we now have only these columns, and we've managed to rename them, which is great. That's exactly what we wanted to do. All right, so the next thing we need to do is check to make sure that there aren't any null values in this smaller set of columns. So let's just go ahead and copy and paste some of our previous code here, and we'll type in core weather instead of weather to work with our new data frame. So let's run this, and we can see we do have some null values in these columns. So let's take a look and see how we want to handle these null values. There are a few different ways we can, but the first thing I want to do is just make sure that we actually want to work with these columns. So I live in Oakland. I know it almost never snows here. So let's take a look at core weather snow to see if we actually get any useful information from this column, to see if it's worth our time to actually fix the null values. So we can see in all of our historical data from 1960, there was only one day where it snowed, and on that day it only snowed 1 inch. So this column isn't going to give a machine learning model anything useful, because there's only one day where it snowed. So if it snows again another day, it's not going to have enough historical data on how snowfall affects the weather to really give us anything useful. So we can actually just delete this column, because it's not going to give our machine learning algorithm anything useful to work with. Next, let's look at snow depth. to see what the value counts are there. Spoiler alert, because it only snowed one day, I'm guessing there was no snow accumulation. So yeah, it's all zero, so we can go ahead and delete this too. Snow depth is just how much snow is on the ground, and since it only snowed once, there was never any snow on the ground. All right. The next column we can take a look at is the precipitation column. This about 1.6% of the values in this column are null. So let's take a look and see what those values look like. So we're going to index for weather by the is null blue. And basically what this will do is it will only select rows where precipitation is null, and it'll show us those rows. So we can see the NaN value, the null value in the precipitation column, and all of these rows, these 281 rows, are the rows where precipitation is missing. All right, so we can see 1983-1029 is October 29th, 1983 is one day where the data is missing. So let's take a look at what happened before and after that. So we can take a look at 1983, 1020 through 1983, 11. It's okay, take it through November 5th. So we can see what happened before and after that missing value. All right, so we can see there was no precipitation, 0 for a while, then there was 3 missing values, then there was a little bit of precipitation. So it's hard to tell what specifically happened on these days, because if it rains one day, that doesn't necessarily mean it'll rain the next day. So what we need to do is figure out what we want to replace these missing values with. There's 2 strategies we could try. We could try the forward fill, which is replace with the value that came directly before. So in this case, a 0. Or we could just go ahead and replace all of the null values here with 0. And that's actually not a bad bet, because most days there was no precipitation. So let's go ahead and run this. We can see the vast majority of days had no precipitation. And there were very few days with a lot of precipitation. So I'm actually going to make the call to go ahead and replace these null values with 0. And we can do that by using fill NA. You might make a different choice here. You might decide on a forward fill or a different strategy, but because so many of the days just don't have any precipitation, it makes sense to me to just assume that if there's a missing value, it means no precipitation. And why might these values be missing? A sensor might have malfunctioned, someone might have forgotten to put an observation in. There's a lot of things that could have caused this. So you could definitely do some research on your own if you want to dig more into why. For now, since we don't have enough time to do that, let's just go ahead and replace this with 0. The next set of columns we have to think about replacing the null values in are these temp max and temp min columns. So very, very, very few of the observations in these columns are actually missing. So that's a good thing. So let's take a look and just see what is missing here. And we can again do pd.isNull to only index the rows where temp max or temp min are missing. So very, very few rows. And we can see there are some where both are missing, and there's some where only the maximum temperature is missing or only the minimum temperature is missing. But it's very, very few rows. So what we're going to use here is a forward fill. So what this does is it finds the previous value that was not null. So if temp max is null for 1120, it goes back to 1119. And if that wasn't null, it uses that value to replace the maximum temperature and the minimum temperature. It does the same thing. So we'll go ahead and do that. And now we can take a look and see if we have any null values. So I'll just copy and paste this code from up here. All right, we have no missing values now, which is great. That's exactly what we want. So the next thing we can do is really go ahead and start to take a look at some of the data types. In a machine learning algorithm, it's really important that the values you're using to make predictions are numerical. So let's go ahead and take a look at our data types here to make sure that all of our data types are numeric, and they are. So that's great. We can also take a look at our index to make sure it's the right type. So our index is actually just an object type at this point, which means it's just treated as a string. But this is actually a date time. These are dates and times. So we can actually convert this to a date time index, which is a specific type of pandas index that is a date time. And that lets us do some nice things, some easier manipulation of values, easier subsetting of groups that we'll see in a bit. But we can use the pandas toDateTime function to basically turn our index into a datetime index. All right, so let's take a look at the index now. And you can see that it's now been converted to a datetime index. So that's amazing. And in a little bit, you'll see the power of a datetime index versus a regular index in action. But one of the cool things we can do is we can actually subset. So if we want to look at things by year, we can say index.year, and this just gives us the years. And you can do it for other parts of the date as well. So if you want to look at just month, etc. And this will be really useful when we try to find things like the average monthly temperature or the average annual temperature. There's one last thing we need to do before we can go ahead and start with doing some analysis and some machine learning. And that's actually in the data documentation. So there's a note here that says, 9s in a field indicate missing data or data that has not been received. So what we can do is go ahead and just make sure that our columns don't have any 9999s in them. And we can do that by using apply, which goes column by column. And basically what we're doing is we're saying, check if x equals 9999 and give us the total count in each column where x equals 9999. Thankfully here, that is not the case. We don't have any of those values, but always make sure you're reading the data documentation and taking into account anything that the documentation tells you to take into account. So in this case, we're good. All right, now we can do a little bit of analysis just to see what's going on with our data. I always like to just plot out some of the key columns just to make sure nothing crazy is going on. It's a nice visual way to just take a look. So this will plot our maximum and minimum temperatures by day. So let's go ahead and do that. All right, so there is something a little bit weird going on. Here you can see there are actually some gaps in it. So we're missing data from 1990 to maybe 1999. And from it looks like 83 to 85, there are some gaps. I don't know why those gaps are there. If you did some more research, you might find maybe something was weird with the airport weather station. Maybe the station name changed at some point. Unclear. What we can take a look at is just a deeper look to see which years we're actually missing. So we can do index.year.value counts. So this will tell us how many observations exist for each year. And then let's go ahead and sort so we can see by year. So this gives us in ascending order by year how many observations there are for that year. So we can see here we're missing 1981 and 82 and some data for 1983. We're also missing 1986 through 1999, some of the data. All right, so in this case, it's not actually a huge deal that we have complete data because what we're using is historical data to predict future data. So if we're missing a little bit of historical data, that's fine. We could go back and figure out how to fill this in if we wanted to. Like maybe there's another weather station close by we could use to fill in this data. But for now, we're not going to. We're just going to go ahead and keep working with it. But at least we know. So it's important to just kind of plot your data out and see if there's anything weird. There's also a couple of outliers here. Like I don't think the temperature has gone as high as 120 in Oakland, and I don't think it's gone as low as 0. But there's only a few of those, so I'm not going to worry too much about them at the moment. We can also plot out the precipitation column just to see if there's anything weird there. All right, and this column looks okay. This outlier you may want to investigate a little bit if you have any strange outliers like this, where this is indicating it rained more than 4 inches in a day, which is a lot, but maybe it happened. All right, so this is just a little bit of exploration. I'll show you another cool kind of exploration you can do. So you can see how much it's rained each year. So you can take core weather, you can group it by year. So this is just creating one group for each year in our weather data. And then you can actually just apply a function to count up how much it rained. So we'll just do sum here. And this tells you how much it rained each year. Don't worry about temp max and temp min. Actually, I'll probably just keep those. There you go. So this just tells you how much it rained each year. So it's a cool way to just be able to see seasonal weather patterns. And there's a lot more analysis like this you could do with this data and with the other columns. That's not the purpose of this tutorial, so I'm not going to dive too much into it, but no, this is a really interesting data set. So the next thing I'll dive into is our machine learning part. And the first thing we'll need to do for machine learning is figure out what we want to predict. So in this case, we're going to try to predict tomorrow's maximum temperature using historical data. So what we need to do is we need to create a target. So this is what we're trying to predict. And we're going to do that by using shift. So shift -1 will pull every row back one position. And we want temp max. So what this will do is create a column with tomorrow's temperature. So let's take a look at this. So we can see temp max, the target is tomorrow's temp max. So for January 2nd, the target is actually the temperature for January 3rd, and so on as you go down here. So what this does is it ensures we're predicting tomorrow's temperature using data from today and previous days. All right, so we've set up our target. You notice there's a missing value at the end. That's because we don't have the temperature data for January 29th. So there's nothing to pull back and use as our target. So we're actually just going to get rid of that row. So we'll just say core weather. So up to -1, so up to, but not including the last row. And we'll just make a copy. So that'll just cut off the last row. Although I think I made a syntax error by using LOC instead of ILOC. All right, so let's go ahead and take a look now. And we can see we don't have that last row with the missing value anymore. So perfect. We're in good shape to actually do some machine learning now. So let's go ahead and import from scikit-learn our machine learning model. So we're going to use ridge regression, which is a type of regression that minimizes overfitting, to start with. So we will set alpha as a parameter that controls how much the coefficients of the regression model are penalized, and the greater the penalty, the more overfitting is prevented. So don't worry too much about the parameter right now, but we'll just pass in alpha equals 0.1. So what did I just do? I just imported the ridge regression model from scikit-learn, and then I initialized the model into this variable reg for regression. So let me go ahead and run that, and it'll go ahead and run the import and initialize the model. And the next thing I like to do is I like to create a list called predictors. So we're really explicit about what variables we're using to predict the target. So in this case, we're using precipitation, the maximum temperature in a given day, and the minimum temperature in a given day to predict tomorrow's maximum temperature. So let's run that. And then we'll split our data up into training set and a test set. So we'll do that by saying up to 2020, 12/31, that is our training set. And then our test set is everything after that. So it's 2021, 01, onwards. All right, so now our training set is everything from before the end of 2020. So it's 2020 and all previous years. Test is 2021 and the first part of 2022. All right, so we've split up our data. And that type of split is really important when you're using time series data. What you don't want to do is use data from the future to predict the past. So we wouldn't want the test set to be 1970 and the training set to be everything after 1970. You always want to make sure you are using previous data to predict future observations, not the other way around. Because in the real world, if you're going to use this algorithm to predict the weather for tomorrow, you don't know what happened in a week or in 2 weeks or in 3 weeks. So you want, however you train your algorithm, to mirror how you're going to use it in the real world. Otherwise, you get overfit, or where your algorithm looks amazing in training and then horrible in the real world. All right, so let's go ahead and fit this model to our data and then make some predictions. So the first thing we're going to do is call the fit method on our regression model, and we'll fit it to our training data set. with our predictors, and we'll try to predict our target. So let's go ahead and do that. So our model has been fit, and now we can generate predictions. And we will generate predictions on our test data set using the predictor columns. All right? So we now have our predictions. And once we have predictions, we can see how well we did. And we'll use mean absolute error to do that. And mean absolute error is basically subtract the actual from the predictions, take the absolute value, and then find the average of that across all of the predictions. So test target is our actual value, and then we have predictions. So let's see what our mean absolute error was. Okay, so this means on average, we were about 3.4 degrees off the actual temperature. So not bad for our first attempt. There's a lot more we can do to continue to improve the accuracy here, though. Before we do that, let's go ahead and just combine our actuals and our predictions. And I love to do this in machine learning applications because I like to see the actual values and the predictions side by side. It helps me see where there are big differences or where I missed something. So we're going to concatenate the actuals, which are test target, with the predictions. But to concatenate the predictions, we need to convert it. The predictions are a NumPy array right now. We need to convert them to a pandas series with the same index as our test data. So we'll go ahead and do that. And then we're going to say concatenate them on axis 1, which means each series is a column, and concatenate them. All right, so you can see that's our actual target, and those are our predictions. Column 0 is prediction. Let's actually just rename the columns here to make it a little bit easier to figure out what's going on. And we'll name them actual and predictions. Okay, let's run that. Okay, so now we can see our actual values and our predictions. So you can use this to really diagnose any issues with your model. So we can go ahead and plot. We can see if there's any cases where we're just way off or things look very odd. You can see there's a few cases where the actual peaked a lot higher than our predictions. And there's cases where our predictions didn't go as low as the actual temperature. So in general, it looks like our predictions are a little bit more conservative than sometimes what actually happens in the real world. All right, and then we can take a look at the coefficients of our regression model to see how the different variables are being used by the model. So it looks like precipitation has a negative impact on temperature, which makes sense. In Oakland, it usually tends to rain in the winter. So if it rained, that indicates to the model that the temperature tomorrow will probably be low. Temp max is obviously the biggest input here. So the previous day's maximum temperature is a big input to tomorrow's maximum temperature. And then the minimum temperature is also a smaller input. All right. So we've come a long way. We just trained a machine learning model, made our initial predictions, and figured out error. So before we move forward, let's go ahead and actually just create a function to wrap up everything we did. So splitting the training and test set and generating the predictions and then combining the predictions together. So we'll create a function. This function will take our list of predictors, the core weather data frame, and the regression model. And in this, I'll actually just copy and paste a lot of the stuff we've already done. So we're going to split the train set and the test set. We're going to go ahead and fit our regression model, and we're going to go ahead and generate prediction. All right. And then we're going to go ahead and generate error, really just copying and pasting here. So error will equal this. And then we'll go ahead and just combine our data frame. And what we'll return from this function will be the error and combine. So we will return that. And what this lets us do is instead of copy and pasting or reiterating the code every time, we can just run this function to create our prediction. So it lets us iterate our model, add more predictors, try testing different models a lot more easily than if we had to just copy and paste the code over and over. All right, so let's actually create some more predictors. So the first thing we can do is we can look at, hey, what was the average temperature this month? So we can do that by looking at our rolling mean. So we can use the pandas rolling method to find a rolling mean for a certain period. So what this will do is it'll look back 30 days from each day and then just find the average of a certain column during that period. So what this says is for the temperature max column, for the 30 days before every row, find the rolling mean and assign it to the month max variable. So let's take a look here. We can see this is mostly NaNs up front because you need 30 days before a row to actually create this rolling mean. So in cases where there aren't 30 days before a given row, it just has NaN. But you can see in these later rows, we do have, this is the mean of the previous 30 rows, essentially. All right. And then we can find some interesting ratios. So we can look at, okay, for this given day, was the temperature different than the monthly mean or not? So the way we do that is we just look at that monthly mean temperature, and then we divide it by the temperature in that day. So this tells you how different is the monthly average temperature from the temperature in a given day. So if a given day just has a really high or outlier temperature, that might give the algorithm some information, and it might help it make better predictions. We can also look at the ratio between the maximum temperature and the minimum temperature. So we'll just divide temp max by temp min. And this could give the algorithm some information. Like if there's a very wide range between the maximum and minimum temperature, maybe that indicates something about what the temperature is going to do the next day. Okay, so now we can use these 3 additional columns we've added to update our predictions. So before, when we created our predictors list, let me just copy and paste that. I will go ahead and add these extra predictors. So these would be month max, month day max, and max min. All right, and we can go ahead and just run our function to get error and combine. So we pass in predictors, we pass in core weather, and finally we pass in our regression model. And we get a value error. Yes, this is because I passed in these NaN values. So actually, I need to remove the first 30 rows of core weather. So I'll use ILOC, and we'll just get rid of the first 30 rows because those have the NaN values for month max. So let's go ahead and run that. And we should now have an error estimate. So we reduced our error slightly. If you remember, before it was 3.4, now it's 3.36. So on average, we were about 3.36 degrees Fahrenheit away from predicting the actual maximum temperature for tomorrow. So not bad, but we could do better. And let's go ahead and just plot our combined data frame. All right, so it's hard to tell what we improved, if anything, here, but it can be nice to take a look at these plots for diagnostic purposes. All right, so next we can add even more predictors. So what we can do is just figure out the monthly average temperature historically in a given month. And to do that, we can actually just take our temp max. So this is our maximum temperature column, and then we'll group it by month. So this is grouping by month in our temperature max column. So it basically groups all of the temperatures for January together, all of the temperatures for February, etc., regardless of what year they fell in. And then we'll apply a function to basically take the mean of all of the values before a given day. What we don't want to do is just take the mean of all of the months, because if your observation falls in, let's say, January of 1970, you only want to use historical data from before 1970 to actually create the average monthly temperature. Because if you include average monthly temperature data from 1990, 1980, etc., it creates the problem I talked about before, where you're using future knowledge that you wouldn't have otherwise had. So we're going to use the pandas expanding function. So what this does is it only takes previous rows and calculates the mean. So let me run this. So basically, at this point, for January 31st, 1960, the monthly average is just this one day, because that's the only observation we have in our data set from January at this point, right? Here, this is February 1960, so this is 62, because the temperature this day was 62, so this is just this day. We don't have any data from February previously. This is February 2nd, so this is the average of these 2 rows. This is February 3rd, so this is the average of these 3 rows, and so on. Whereas if you look at January 2022, this is the average of all the temperatures in January that came before this observation. So I hope that makes sense. But this is a way that prevents us from using future knowledge to influence our past predictions. All right, so we have the monthly average. We can also look at the day of year average in the same way. So we'll again group by. But we will group it by a different property this time. So we'll group it by the day of year. So day of year is a fancy property of a date time index. Remember how we converted the index to a date time that gives you in the year which day is this. Is this day 1? Is this day 90? Is this day 120 in the year? So, and we'll do the same apply part here. All right, so this gives us the average temperature for that day in the year. So if it's the 30th day in the year, it gives you the average temperature for all previous 30th days of the year. All right, and now we can try again. And I'll just copy and paste because we're just passing in the same parameters to the function. All right, let's see what happened to our error. All right, our error has not gone down because I did not update our predictors. So let's go ahead and update our predictors to add these new predictors. All right, so we'll add in day of year average, and then we'll add in monthly average. All right, so our error has gone down slightly. So it's gone from 3.36 to 3.31. That means on average, we're within 3.31 degrees of the actual temperature, either below or above when we're making predictions. All right, and we can again take a look at the coefficients of the regression model to see which variables are being used and which ones aren't. So we can see precipitation, temp max, temp min, month max, month day max, and then the day of year and monthly averages. We can see the ratio between the average temperature in the last 30 days and today's temperature seems to be fairly significant to the algorithm. All right, now we can take a look at correlations just to see which columns correlate with our target. This just helps us diagnose and see if the predictors we're passing in actually make sense. All right, so you can see a lot of these columns are very highly correlated to the target we're trying to predict, which is great. It means as these columns vary, as they go up or down, the target also varies. All right, so looking at these correlations is one good way to take a look at, okay, which predictors do I want to use? Which ones do I not want to use? Another thing we can look at, if we want to go ahead and improve this model, is we can actually take a look at the difference. So the difference between the actual value and the predicted value. So what this will give us is the absolute difference between the actual values and the combined. So it just removes the negative sign. That's what ABS does. It gives us the absolute value. And then let's go ahead and look at the biggest differences between what the actual temperature was and what we predicted. All right, so here we can see the top 5 rows where our actual value is different from our predictions. And what you could do, I'm not going to do it right now, but you could dig in and really look at, okay, why did this happen? Is there any other data I could add that the algorithm is missing? All right, so I'm going to stop here with our guided tutorial and our guided steps. There is a lot more you could do here, though. Weather prediction is a really interesting problem with a lot of nuance. So I'll give you a few next steps you could try here. So the first next step you can try is you can try to predict the weather for an entire week instead of just a single day, right? It's not as useful in human terms to say, here's the temperature tomorrow versus here's the temperature for the whole next week. So you could try doing that. You could try using data from more weather stations. So we just have data here from a single weather station. You could try using data from other close by weather stations to either fill in some of the gaps. Remember, we were missing some data from 1986 through 2000, to either fill in gaps or just add more sources of temperature data. So you could try that. You could use more of the predictors in the data file. Remember, if we look at the data documentation, there are a ton of other predictors in that data set that we didn't use that you could easily use to see if they improve prediction accuracy. You could create more of your own predictors. So we went ahead and created some predictors like the monthly average temperature, day of year average temperature, etc. You could create a lot more predictors like that, which can be really useful for making a more accurate model. You could try different algorithms. We only used a linear regression model, ridge regression, but you could try different models as well. And then finally, you could set up backtesting to make predictions for every single year. We only did predictions for 2021 to keep it simple, but to get a more robust parametric, you could create predictions for many, many different years using backtesting. And I've talked about backtesting in some of my previous videos, and there's a technique for how to do it there. So there's a lot more you could do with this. Predicting the weather is a huge problem. It's easy to get started with, as we saw, but there's a lot of depth you can add on, and you could spend months or years on this. There's a lot of data out there you can get. There's a lot of different things you can try to improve accuracy. So this is a fun starting point, but it's not the end. Please feel free to continue building this out. And if you do create anything interesting, please share it in the comments. I'd love to see whatever you come up with. Well, thanks for joining me today. And I hope you have a really, really good rest of your day and good luck with the project.